Yeah, hi. Good afternoon, everyone.
Good
Good
afternoon, sir.
afternoon, sir.
Okay, so welcome to the third session for the C programming. We have conducted on Tuesday, second Thursday, and this is the third Saturday session. So this is the fixed schedule of the live sessions for C programming. So every Tuesday 6 to 8, and every Thursday 9 to 11, and every Saturday this 12 to 2. Okay. And I hope you have get the access of each live session on the portal itself. Let me share my screen and show you all the details you will get on course page also. Okay, so you can see we have released this live session one tab where you can see all the information about the timings and meeting link. So if you have not added the calendar, so many of you maybe are qualified students and you are not aware of this Google calendar or these things. So still you can see the all information of the live session in the course page itself. Okay, so this is term namespace, same we have also released on the qualifier namespace. Okay, it's qualifier portal. So also, if you suppose miss some session due to any reason or something, so still you can see all the live session on YouTube. So we are recording this live session on the YouTube, as well as we have also released this sheet, Google Sheet. So this is the one Google Sheet, and you can see the details, the what session we have already done. So you can see 14 Jan we have conducted one session, and 16 Jan we have conducted one session, and now this is the today. So we will update after this session. So all recordings are available, you can see later again this session if you missed. So that is not a problem. So supplementary content, we have released the PPT slides, and uh, very soon we also release some week wise notes also, okay, in here. And if you want to get the notification for each live session, add the Google Calendar. Okay, this link is given inside the general instruction and important link calendar for this course. So please add this link in your Google Calendar. So you will get all schedule in your Google Calendar. So when is the live session? Also, you will get a notification before 10 minutes of the live session. So no need to wait for like a notification WhatsApp announcement. Sometimes maybe that WhatsApp announcement missed, so do not miss the live session. These are the fixed timings of the live session also. Okay, and once you will add the calendar in your Google Calendar, you will get all update also. So maybe later we will also add some live session, like additional live session for the coding practice. So that will also be reflect on the Google Calendar. So these are the required things to just keep update yourself regarding the live session or classes. Okay, so I hope so you have already seen. So I think 1 week is already done approx. So I hope you have already seen the week 1 contents. Okay, and I hope you have also tried the assignments. So this week, first week and second week, we are only covering the basic about the computers. So first week is only about the computer, second week about the number representation, how the data representation in the computer. Okay. So if you have any query in the week 1 or any query if you have, you can ask. Initially, you can raise the hand. I'll take your query if you have any doubt which is not cleared before in any session. You can ask. Anyone have any query? You can raise the hand and you can ask. Second, let me- yes, Mohit.
Yeah, sir. Before the OPP session, we will practice our coding.
Yes, yes. So
Okay.
from week 3 onwards, you will get a programming assignment on your course page itself. Okay, from week 3, graded programming assignment, practice programming assignment will also be the part of your assignments. First
Okay,
two
sir.
week,
Because
first 2 week you are getting only this
now I
practice.
am a new student. I did not know anything about it.
we know that. We will definitely we will practice in the live session also. So because this Saturday session is also dedicated for the coding, live coding session. Okay, but initial first these 2 weeks we don't have much content in the that week contents regarding the programming. So we are not okay discussing too much about the programming in first 2 week, but I'll discuss about the computation logic or these things today also. Okay, um, and we will also start with the
Okay, sir.
basic
Thank you.
programming. Hmm.
Thank you.
Okay, yeah. Uh, okay, anyone else with any query? Any topic in week 1 which is not clear? Okay, no doubt. Okay, last week I think practice assignment is not discussed. So first thing I'll cover this practice assignment. Then after that we will discuss about the computations part, how we actually think about the logic or what is the algorithm, what is the pseudocode, what is flowchart. We will discuss little bit about this, and we will also discuss the basic code structure of the C program. Okay, so uh, okay, so let's start with the practice assignment. Okay, if you don't have any doubt, so I am just moving to the directly practice assignment. Okay, if you have any doubt, you can also ask. So here, okay, Sayed, yeah, go ahead.
Sir, I have a doubt in the sum of n numbers.
Sum of n number. Okay, so what is your doubt?
So my doubt is how can like we have some question in which we have to write the R0 like less than n. So how can we find that?
Okay, 1 second. Can you repeat your question? So your problem is like sum from 1 to n. This is the
N,
problem.
yes, sir.
So what is your doubt? Can you repeat again? So,
So like we have given some number and
huh.
then we have some conditions like R0 is less than n. So we have some question in which we have to write that R0 is less than n. So how can we find that? This number should be less than n. We have some question in the practice assignment also.
Okay, okay. So let me open that assignment. I'm not getting the complete things. 1 second.
Okay.
Hmm. I think this question you are talking.
Yes, sir.
Okay, okay. So this is the conditional statements. Yeah, that I'll discuss during the all practice assignment. Okay, so how we solve this type of questions. Okay, fine. Yeah,
Okay,
that
sir.
I'll cover it. Good.
Okay.
If this is the practice assignment. Okay. Any other doubt? Okay. So let's start with the first question. You can also give your view. Okay. So just raise the hand and think about what should be the answer according to you. Okay. So that will help you to understand what you actually think about the questions. So first question: which of the following statement best describe programming? Yeah. Good afternoon, Brijesh. Okay. So here four options are there. Which of the following statement best describe programming? 1 second. Where is the pen? What a pen. Big pen. Okay, got it. Okay. So the first statement is it refers to how the data is organized and stored in the computer memory. Is this programming?
No, sir.
No,
No.
sir.
No, sir.
Okay, 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 good. It refers to the process of instructing the computer to perform a given task.
Yes,
Yes,
sir.
sir.
Okay.
Yes,
Okay.
sir.
Yes,
Correct
sir.
answer.
It and another is it refers to the hardware that a computer can support.
No.
No.
No, sir.
Okay, so here in out of these three statement, last one is the all of the above, so that doesn't matter. Okay, so this second statement is more related to the programming term. So simple program, what is the program? Is a set of instructions. Okay, and programming means we are just telling, we are just instructing to the computer. So what should be the sequence of instruction to perform any task? So that is just like a programming. Okay, we will just instruct or we will just tell to the computer, so what operations, what should be the sequence of steps, what should be the sequence of instruction, so that computer will, what computer is just a machine. Okay, so computer will only execute step one by one. What sequence we are providing to computer, that only will execute one by one. Okay, but our sequence order should be designed in this way, so that will solve our problem. Okay, so that is actually a, program, or sometimes we call this also as a algorithm. Okay, what is the algorithm? So algorithm is also a set of instruction or step by step instructions. So that is also algorithm. Okay, programming basically, if we use any particular language syntax, so that is called as a program. If we convert our steps or our logics or our instructions into a specific programming language, so that become a program. So this first question, second option is more clear regarding the program. Another step, another options are not too much related about the programming. Okay, so that is just regarding the computer but not the program. Okay, so second, which of the following is a not valid logical operator in programming?
Assignment and cost.
Assignment
Assignment
and
and
course.
course.
Okay, so the here this is MSQ type of question. So you know what type of questions we are providing in the quiz exam, sorry, quiz assignment. So that is one MCQ type where the one answer is possible. Second is MSQ where the multiple answers are possible. Some questions will also come like as a numerical input. So where you have to put some input for the answer. So that three type category of questions we are considering inside the assignments. These. So yeah, which of the following is a not valid logical operator in programming? So first is and, not, assignment, and cause. Okay, so cause, there is no, this is not the operator actually. Okay, and we not use this in the programming. Assignment is a operator, but that is a different category that we always get as a assignment operator, not the logical. So here the only answer is okay. So we are asking not valid logical operator. Okay, so this assignment and cause are actually not logical operator. So and, not, or another operator, if you can remember, can anyone tell me other than this and or not?
XR.
Or
Or
So,
Okay, and, not,
or
or
that's all.
XOR,
XOR.
XNOR, NAND.
That
and so on like
okay. Okay, okay. So that, I think you are moving to the all completely electronic side, like digital electronic side. Okay, but yeah. So actually, we only use this and, not, or this operate logical operator in the programming, not out of this. So why this is used actually? This used to combine the condition actually. Suppose if we are just writing a program where some conditions are required. Okay, so you know about the conditional things. Suppose if you are checking number is a, you have to check some comparison, or you have to check some matching like this. If you have, so condition means that condition will always return a true or false. Either this will condition will be true or it will be false. So if we have more than two condition, more than one condition, so how we are combining that condition? So what should be the output after combining the condition? Suppose we are looking the numbers from 1 to 10. 1 to 30. Okay, I'm just giving this example. 1 to 3, we have this number, and we are looking the number which is divisible by 3 and 5 both. Okay, we are looking the number which are divisible by 3 and 5 both. So how we will check this? So that means we need, so here the condition is the number should be divisible by both, not only the single number. So in that case, we have to put AND logical operator in between these two conditions. So we will check that. So suppose we are taking I, okay, I equal to 1 to n. We are taking number one by one. So I is reading 1, 2, 3 like this, and every number we will check that if I is divisible by 2 or 3. Okay, and this we will match like this 0. Okay, this is the one condition, and I divisible by 5 equal to 0. So what is the meaning of this condition is we are dividing I by 3, and what is the remainder we are getting? So that remainder is equal to 0 or not. So we are comparing left side, this side, and this side. This is the comparison operator. Okay, double equal to means we are matching the left and right side equality. If this is equal or not. So I divided by 2, I divided by 3. If remainder is 0, so that will return a remainder. If this is matched to the right value, so that means this I is completely divisible by 3. Similarly, this we are also checking I is completely divisible by 5 or not. Okay, so this is the condition actually. This is the suppose C1 condition. This is the condition 2, C2. Now both should be actually satisfied. So we have to apply the AND operator in between. Okay, so AND. We can write like this AND. Okay, AND operator. So in that case, if both will be true, so I know, I hope you know about the truth table of this AND not or. So according to the AND, if both conditions are true, then overall output will be true. Okay, so if condition C1 is true, C2 is true, then this overall condition will be true. Okay, same thing if anyone is false, our overall output will be false. Okay, in the or case means either any condition is true. So suppose C1 is one condition, C2 is another condition, and we are applying or in between. So according to the or, if either condition C1 is correct or true, or maybe C2 is true, overall will become true. Okay, if any condition is true, output will be true overall. So this is the or logic. Okay, so T, if this is T, so then output will be T. Okay, if both are false, then only output will be false. Otherwise, always that will be true. All other conditions. So T, F, T, like this. Okay, and this not is just a revert a output actually. Okay, suppose if your condition is returning a true, and we just before that we mention not, so that will our return output true will become false. Okay, so we are checking if this condition is not satisfied like this in this way. So this is just reverting inverting the true to false, false to true. Like, so these are logical. We will also discuss these in when we will start the C basic syntax from week 3. Then we will use these operators in our C. Okay. So all these things are logical operators. So for second question, the answer is option D, C and D. Okay. Which of the following statement is generally true? Okay. This is regarding the basic computer architecture, which we have discussed in the week 1 content. So just read the statement one by one and see the correctness. Okay. The memory unit is responsible for performing arithmetic operation in a computer. You know about the CPU? Yes, Shivam. Shivam raised the hand. Okay. So okay, you know about the CPU structure?
Yes, sir.
Yes,
Yeah.
yes, sir.
Yes, sir.
Okay, fine. So basically CPU, that is just a unit that contain one control unit, okay, and ALU and registers also inside this, okay. Registers, multiple registers are there, registers. Okay, and we have some memory other side, so that is maybe generally we call as a RAM, and this unit is communicate with this memory and get the data inside the registers, and that registers data is computed by the ALU, and the output data will return back to the memory, main memory. So this is called also as a main memory. In between we also use some cache memory that increase the computation speed or memory access speed. So some processor contain this cache memory inside the CPU maybe, but sometimes it may also be in between the memory and CPU. Okay, so this is like a CPU cache memory. Okay, so the memory unit is responsible to performing arithmetic operation in a computer. No. Okay, so memory store the data only. So what actually instructions we are giving to the perform any task, so that set of instructions relate required data. Okay, so any instruction we are performing on data, so every problems has always have some data, and we just process that data, and we perform some logic on that, and then we get some output. So that is the mainly actually the programming. So this RAM contains the data and instructions, and that set that is passed to the CPU actually during the execution. Okay, so this option is not true, and the registers are responsible to performing arithmetic operation in a computer.
No, sir.
This is also not correct, because registers are also a smallest memory. Okay, this is also a memory that store the information which is required by the ALU. So that is registers also consider comes under the memory category. ALU is the responsible for performing arithmetic operation in a computer. Yeah, this is
True, sir.
arithmetic logical unit is actually perform the mainly arithmetic and logical operations. So option C is correct for this. Okay, so let's move to the next. Which of the following statement is a true for a split memory architecture? Okay, so that we have already seen in the lecture. The ALU fetch, the ALU fetch, write, okay, fetch and write the data directly from the main memory. Uh,
True.
No, sir.
No, sir.
False.
No, no, false, false.
Okay, the input data is fetched from the main memory and is temporarily stored in the register to perform computation. Is this
Yes,
true?
sir, true.
True.
Okay.
Yes,
Yes,
sir.
yes.
So ALU actually not directly read the data from main memory. The data comes under into the registers, and then ALU interact with the registers. Okay, so this is not correct. The result of the computation is temporarily stored in the registers until it is written into the main memory. This is true or
True,
not?
True.
true, true.
True, sir.
This
True.
is true. So yeah,
First option is also true.
first option is also true. Okay, ALU fetch and writes the data directly from the main memory. Is this true?
No, sir.
No, sir, this is
No,
false.
actually, ALU take data from the register, not directly from the main memory.
Register take the data from the main memory.
So data is actually, so control unit actually manage all these read and write things. What is the next instruction to be read? So some registers also contain this information, and control unit decide all these things. But data actually comes into the registers first, and then through the registers that it moved to the ALU, actually CPU, or sometimes be also called as a processor. Okay, so
Hello, sir.
yes.
I didn't understood split memory architecture. Means
Split. Uh-huh.
I didn't
Okay.
I didn't attend previous class. That's why I don't know.
But you didn't watch the lecture also?
I missed sir.
No, 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 I'm not talking about the class. Here, some professor recorded lecture also is given as a content. So that have you watched that?
Sir, I did.
So I'm talking that these professor lecture is also given. Okay. So the way of learning these courses are, so these professor lectures are available in your content. First, always watch these lecture first. Okay.
Okay, sir.
And after just after watching the lectures, just collect your doubts. Okay, and then we are conducting live sessions, so just join the live session. If anything is not clear, then ask in the live sessions. Okay, so that is the good way to learn these courses. So you have two way, so professor video you can learn, you can watch, you can understand the things. If the still that is, topics are not clear, you can join the live session and you can ask, clear your doubt. Okay, but if you are not watching lectures, you are not attending live session, so that will be difficult for you also to solve all the assignments, all or also in the quiz exam, all these things. Okay, so split memory architecture, so that is okay, I have to open the slide then. 1 second. I think this slide is also discussed in the previous lecture, previous live session. Okay.
Yes, sir.
1 second. I quickly go through this one. Okay. So split memory architecture, this memory realization. This split memory architecture, you can see. This is just a architecture how actually a computer works. Okay, what how the connections are happening. You can see here. So this is just a large memory. Okay, it is mentioned large memory. Generally, we call this as a RAM or main memory. Okay, so that memory is volatile memory. If you will turn off the power, your data will be removed from this memory. Another memory we have like as a permanent memory, generally we called as a secondary memory. That is where our data is always stored, that is not lost if our power if we turn off the power. Okay, so this large memory or called as a main memory is connected to the CPU. Okay, this is the part of CPU. Inside you can see this is the main part we consider as a ALU. Okay, so this is main unit ALU. So now registers, this part is called as a register. So these are the intermediate part of the CPU and main memory. So our data comes to the registers, and our that processor or ALU unit actually fetch the data from registers. And because what is this ALU means, actually this is just like a processor, it is executing instructions. Okay, and one instruction may need some data to execute. Suppose we are performing like a equal to a plus 1, this operation you are performing, that means you are incrementing the value of a. So this operation required what is the current data of a. Okay, and that will be incremented by 1. So that current data of a will be stored in this some registers. Okay, maybe R1 R2, the multiple registers are there. So some registration this data will be available, so that data will be fetched through the registers and value will be incremented by 1, and then ALU unit will return back the updated value to the registers. Okay, and once that purpose is finished for this a variable or this instructions, that this instruction is completed, the final updated data is now moved back to the RAM memory. Okay, So this is the way of the communication of data in the main memory to CPU. So this architecture is called as a split memory architecture. So some operations are performed like this: load and you can see load and store. How the CPU and memory is communicating. So any instruction or any data is required from the main memory. There is one operation, load. Okay, so that load means we are just fetching some data from the memory to the registers. Store operation means we are just storing some data from registers to the memory, main memory. Okay, so these are some operations which perform between this memory and CPU. So this is called as a split memory architecture.
Thank you, sir.
Okay, yeah. Okay, someone raised the hand. 1 second. Yeah, Utkarsh, go ahead.
Sir, previously you said that a computer executes any command step by step. So it is because we are using C programming to command it.
No, C program doesn't. Here we are not saying that computer always use C programming. Okay, so any programming language, finally the computer execute the machine code.
It's an ideal condition.
Ideal condition means, sorry, I'm just saying that so computer, what computer is doing, any task if we are running on the computer, so that task is just a set of instructions. Okay, some set of instructions we are passing to the computer, and the computer is that our CPU is just executing that sequence of instructions one by one, and our task is performing. So that is the main idea of the programming. Okay, so that code may be written in any language, but finally that code is actually converted into a machine language. So our computer not directly understand our C code. Computer only understand the binary instructions, so that is called also as a machine code, and sometimes we also call it as a assembly language. So all these high level code, high level programming language, C, Python, Java, all these are called as a high level programming language. These these code we can easily understand, but computer directly cannot understand these codes. So these code first convert into a machine code. Okay, and then machine codes are just like a set of instructions which machine actually understand. So that set of instruction executed by the ALU.
Thank you, sir.
Okay, okay, now let's move to the next. So this so we have discussed this. Okay, yeah, fourth question is done, I think. So what was the option? Second on this one. Okay, yeah, this one. Now, fifth question. Which of the following statement is correct? So now, I have discussed these things. So load refers to the process of moving the data from main memory to registers. Is this correct?
Yes,
No.
sir.
This is correct. Load, I have mentioned that we are just reading the getting the
Yeah,
data
yeah,
from
it's
main
correct.
memory to registers. So this is true, and a load refers to the process moving the data from registers to memory. So this is not correct. Okay, this is the store operation. And store refers to the process to moving the data from main memory to register. So this is also not correct. And
No.
last is correct. Store refer to the process moving the data from registers to the main memory. So this is correct. Okay. So now next. Okay, so it typically CPU keeps track of the positions of the next instruction using A. So we have some specific type of registers that purpose is predefined. So what they will actually do? So CPU keep track of the position of the next instruction, which next instruction will execute by the CPU. So that information you can just remember this. This is there is a registers program counter. Okay, so this is the one registers that is used to store the address or next instruction position which will execute. There is one also a register, instruction register, so that store the current instruction which actually is executing. So program counter contain the position of next instruction. So option A is correct for this. Okay, so next is yes, Santi Priya.
Sir, I want to know what is the function of this loop counter?
Loop counter is nothing. So this is, we can make any registers as a loop counter. Suppose any operation is performing multiple times. Okay, we want to perform the same type of instruction multiple times, so we can just define one registers as a counter. How many times we want to perform any particular instruction, so that we will set like as a suppose we have one registers. suppose suppose we have one registers r1, so we can make this as a loop counter, and we can initialize with some value like 0 or something. And every time when we are performing some operation, we will increment this r1 value by 1. Okay, so suppose we want to perform any instruction 10 times, so every time we will just increment this r1 by 1, and we at the last point or in the iteration we will check the condition. If r1 is less than equal to 10, then we will repeat our task. Okay, or inside our task, every time we will just set like r1 equal to r1 plus 1, and initial value is r1 equal to 0. So in this way we are making this as a loop counter. So this is just counting a iterations of the loop by just changing the value every times.
So, sir, how it is different from the program counter?
Program counter is a totally separate registers. Okay, so that contain the address of the next instructions. This is not like a counter. Okay, the name is program counter, but this is just like a registers. We can just give another name like rp, and that always store the address of the next instruction which will execute next.
Okay, sir. So basically, there is a difference between program counter and loop counter. Is program counter is tracking the instructions, and
Hmm.
loop counter is creating the follow
No,
that instructions.
not follow. It is just used when we want to perform execution of one instruction multiple time. So loop means repetition of the same instruction or some set of instruction.
Okay, sir.
Okay,
Got
so
it.
and we are just keeping some value that how many times we have repeated our instructions, so that we are just keeping some that counting value in our registers.
Okay, sir. Thank you.
Okay. Uh, okay. So next question is which of the following is a true for the C programming language? Yeah, these are some properties regarding the C programming language. Okay. So have you seen this property? What is the meaning of this?
Yes, sir.
Okay, which one is the true?
Uh, First option is true because programming C consists of sequence of commands executed a step by step,
Okay.
and option 2 is also true.
It is statically typed language.
Yeah,
Okay, what is the meaning of this?
because the meaning of this type variable is determined at compile time, and
Hmm.
once it cannot be changed after the program executions.
Okay, nice. And it is strongly typed language.
No, sir.
No, it's
Okay.
false.
Why? Okay, what is the meaning of strongly typed? Anyone? Okay, let's this discuss later. Okay, it is structured programming language.
Yes, sir.
So structured means
We have to describe all the variable we insert in the program.
variable things. Okay, and it demands a high capacity hardware.
No.
No. Okay, so
No, it
C
assumes
C mostly used on the that hardware low level machine. So C also used sometime on, and we also use the C programming as the for the embedded microcontroller also. So it not requires too much high capacity. So that is used with the minimum capacity hardware also. So that is not true. Yeah, Arvind.
Sir, strongly typed means I was saying that C is a weak language because you can easily change from any data type to other data type. For example, you can change it from int to string or something like that.
Int to float or float to int like this.
Yeah, yeah. So it is a weakly typed language.
Yeah, correct. Okay, so it demands. So this is also not true. Okay, so these first, second, and fourth option is true for the C programming language. So you can search about the properties. What is the meaning of each these statements? So this is just like a basic of the C actually, just theoretical things. Okay. Now comes to this computation questions. Yeah, this is important for the quiz also. So this type of question you can expect in the quiz exam. So maybe one two question, and let's solve this. Okay. So here information is given like consider the following steps to compute the value of a into b. Let's a and b be located into the memory location m0 and m1, and r0, r1, r2, and r3 are the available registers. So the result to be stored at memory location m2. Okay, so we are computing this a into b value, and we have the data stored inside these registers. Initially these a value is stored at m0, and m1 is the b, and this is the sequence of steps we are performing. Okay, so what it is asking, identify the appropriate instruction to fill in the blanks at step 7. So okay, here steps are given, and you need to identify that which one is the correct to computationally computation correctly. So this computation should be performed correctly according to the problem. Which statement should be filled at the seventh instructions? So what you can do to understand to solve this question, you can take some small value for a and b and see how this is, set of instruction are actually performing your task, because a is and b is just like a label, but we can take some value like a value is like 3. Okay, a value is 3 and b value is suppose equal to 5. Now we can just track how this computation is happening, and how we can track. So we these registers, so we have how many registers we are using. So we have r0, okay, r1, r2, r3. Okay, these registers we have. So now initially r0, you can just note down all these information instruction by instruction. So how we are just performing. So r0 is assigned with 0. So this value is assigned with 0. Okay, first step. Now r1 is assigned with m0. So this is like a. Okay, and m1 is a b. A we are taking 3 and b we are taking 5 to understand this. So now r1 we initially we can see that this is 3, and r2 is now 5, correct? So this is like m0 and m1 we have initialized first. Now r3 is also set to 0. So this is the initialization happening in the first 4 steps. These data is stored in these registers. Now next instruction is R3 equal to R3 plus R2. So R3, this is this operation. Okay, so R3 we are updating in this instruction. So R3 equal to R3. So what is the current value? So what is the meaning of this syntax? So R3 equal to R3. So what is the current value of R3? 0. Correct? Just see what is the current value of the R3. So this is
0.
0 plus R2. What is the current value of R2?
5.
This is
Uh,
5. Okay. So 0 plus 5. And this total is 5. And this 5 is now assigned to R3 itself. Okay. So that means now here data is updating of the R3. Previous data was 0. But now after calculation, this data will update. So that means by this operations, so this data is now updating to the 5. Now it become a 5. So in this operation, so what we are doing, we are just performing this type of operation. So R3 equal to uh, R3 plus R2. Okay, so R2 is basically 5. Okay, now just do this. What we are doing with the another variable. So R0 equal to R0 plus 1. So R0 equal to R0 means so this value. Okay.
B.
So what is the current value of R0? 0 plus R1 plus 1. Okay, so this become a 1. So now R0 is incremented by 1. So this will be updated by 1. Correct? Now, okay. So here now steps is missing. So and finally our output we will store here. So what type of steps we have? We have the steps for the conditional ways. Okay, so conditional ways. All are conditional statement and we are moving back actually. Go to step 3, go to step 5, go to step 3, go to step 5. So we are moving into the back step and again we will start the execution again. Okay, so here you can put you can solve this problem either by just putting this statement and check you are getting the correct output for this 3 and 5 calculation or not, or you can just understand the process to make this correct. What type of operation actually we are trying? So here we are performing increment operation. You can see we are just incrementing this value R0 by 1, and this place because finally we are storing R3 to the M2. So R3 should contain the final result. Okay, so how we are just incrementing this? So 0, now we have added R2 value one time. Okay, so that incrementing operation is performed one time means we have added 5 value R2 value into R3 one time. Okay, now we want how we can get this output A into B, A into B, 3 into 5. So how we can get this? If we will perform this 5 plus 5 plus 5 three times. Okay, so if we will perform this B plus B plus B dot dot dot, how many times? A times. A times. Okay, so we will get the same result 3 into 5.
Yes, sir.
Okay, so same thing is happening in this first step. Initially we said the final result is 0. We have added the R2 value and we incremented one counter for this. That means we have added one time. So this is now become a conditional variable like a loop counter. Okay, we are using this as a loop counter. This registers we are using as a final result. Every time we will add this into the R2. And how many times we will perform this loop counter? R1. Okay, this 3 1 value. So this in this way you can make the decide the condition. So that means your R0 loop should be run till this 3 value. Okay, this was initially 0. Then this condition should be, you can see R0 is less than to R1. This is now become a condition because R0 we are using as a loop counter, and this should be go till less than to this 3 value. So 3 value, why we are taking less than? Because we are starting 0 0 0 and we are adding one time. Then we will increment 1. So 1 and then 2. So you can see 3 in 3 steps. If we will repeatedly perform this operation, so 0 plus 5, then again 5, then again 5. Okay, so you will get a total of answer 15. So the 3 into 5 is 15. So this condition R0 and R1, R0 and R1. So now two options have this condition. R0 is less than R1, R0 is less than R1. So this is the first thing. Now the steps, which steps we move back? Go to step 3 or go to step 5?
Step 5, sir, because M2 assigned with R3 operation.
Correct. If you will move to the go to step 3, so what will happen? Actually, the final result R3 will also be assigned to 0 again. But we don't want this because we want to add into the previous value. So 0 plus 5 become 5. Next 5 will be added into this. Okay, 5 plus 5. So this will become a 10 like this. Okay, and next 5 will be added into this. So 10 plus 5, 15. So in this way, you will always add a into the previous value. Not so if you will move back to the third step, so it will actually reset to 0 again. So you will get you will lost your sum. So 3 step is not correct. If you move to the go to step 5, so only this step number 5 will execute again, then 6 like this. Okay, so this part we are repeating. By this part 5 we are repeating. Okay, so if you will do this, your computation will perform correctly, and you will get a this output A into B. Okay, so in this way you can figure out what we are trying to do in the computation, and based on that you can conclude the answer. Or if you are not getting the logic correctly, so you can just put the option. It will take more time, but okay, if you are putting one option and see are you getting the correct output or not. Okay, so in this way, you this type of question you can solve like this. Just maintain, just write all the registers, how these registers are updating. So in the first step you can see we get 5, then this R0 will increment 1, then we will get it 10. Okay, so now counter will reach at the 2, and we will add a 15, the counter will reach at a 3. But this become a terminate condition. So this 3 is not less than 3. Okay, R1. This R0 is less than R1. So this condition is not true, false. Okay, this is equal, not less than. So in that case, your process will stop. Okay, and finally, what is the finally updated value in the R3 registers is 15. So 15 will be assigned to M2, and you will get an answer. Okay, so in this way you can solve these. Just keep track all the value correctly on the registers, what update you are doing by the each instructions, and how the values are updating. Always use the last updated value into the next instructions. Do not use the previous value, because every time if you are updating any variables, so that is actually overlap the last value, overwrite the last value. Okay, I hope this is clear. Any doubt in this computation? Okay, so let's move to the next. Okay. Question number 9. Suppose two device monitor and keyboard are mapped to a memory location 51 and 50, this 67. Okay, so monitor is assigned to 51 and keyboard is assigned to 67. We have to write a program which takes an input from the keyboard and display it to the monitor. Identify the correct steps. Okay, so some memory is mapped with the monitor and keyboard. Okay, so if we are pressing some digit or something from the keyboard, that data will be stored into this location. Okay, if we want to display what we are pressing into the keyboard on the monitor, so that data should be read and to store at this location. So monitor is reading the data from this location. So for this process, what should be the correct step? So read the value of memory location 67 into the CPU registers R. Okay, so we are reading the value from this and write the value of the registers R to the memory location 51. Is this correct?
No.
Okay, why not?
Because of The value of location 51 will be read
Write the value
because
of registers are.
monitor has to present their keys.
Uh, okay. No, no, you are not getting the point. Actually, monitor is always reading the data from this location. What should be the actually display? Okay. When we are always pressing any key, that data is stored at this location. So we want to display what we are pressing by the key. So how that will be actually displayed? So for this operation internally, what operation should be, what steps should be performed? So what data is pressed by the keyboard is currently at this location. So we should read the data from this location and should write the data at this location. Then memory will that monitor will read from this location. So that will be displayed. So is this not true?
It is true, sir.
This is true because read the value of memory location 67 into
Yes.
a CPU registers R. Okay, so we have some registers. So
Then it display in monitor.
so we are reading the data from this memory location and we are writing this registers value into this location. Then monitor will read that data and will display. So our task will be performed. So option one indicating the correct option. So second is read the value from memory location 51 and R and write the value to the registers R to the. This is incorrect. Okay, because our task is what we are pressing from the keyboard should be display. So here this is the totally reverse operation. Okay, that will not perform our task. Write the value of the registers R to the memory location 51. Write the value of registers R to. Okay, so we are not reading the data into R. We don't know what is the value in R at this step. Okay, so that is incorrect, and we are directly writing into this location. Okay, without reading. So that is not also correct. Write the value of the registers R into memory location. So same things. Write operation at the first step is not correct.
Read the value of the
Huh.
memory location.
First, we have to read the data correctly and we have to write the data at correct place. So writing directly R because we don't know what is the correct current value of R right now. So the first step, first sequence of a step is correct for this operation. Now next is a set of stored instructions used to direct your computer central processing unit is called a.
Is it program, sir? Program?
This is the program. I think this is the reverse question of we have already discussed before. Okay. And next is which of the following component is responsible for mapping the flow of data between the CPU and other component? Control unit. Okay.
CU.
So,
CU.
CU. That manage all these things, data flow and all communications. So this is CPU. Cache memory just contains some data which is frequently coming into the CPU from the main memory. Okay, so suppose some data is repeatedly coming again and again from the main memory. So that frequently repeated data will stored into the cache memory for the some time. So if next time if the same data is required, so that data will be checked in the cache memory first. Okay, and cache memory is faster than RAM and also more closer to the CPU. So that will actually take less time to get the data from cache memory to the CPU. So this will increase the computation speed. Okay, if any data is coming repeatedly, so that data is stored for some time in the cache memory, so that increase the speed. Okay.
Sir, cache memory is also faster than register.
No. Registers are more faster. So actually, regarding the closeness, okay. So which memory is close to the CPU? That will take less time to the communicate. Okay. So the if we talk about the speed, is a point of view from
Cache
the
memory is
CPU.
present in the SSD of computer.
Which computer?
Cache memory is present in the SSD.
No. Yes, sometimes actually some of the that RAM memory is used as a cache memory. So this is the architecture dependent actually, what the computer dependent. It's not a specific. Sometimes cache memory included into the CPU itself. Sometimes it is not included. Some CPU that not contain the cache memory within the CPU. Okay, so this is just totally machine dependent. So how the machines are designed actually.
Okay, sir.
Okay, so next is which of the following component is responsible for temporarily storing instructions and data during program execution?
RAM.
Hmm. Okay, so all others are actually CPU is the totally different unit. But floppy disk, hard disk, these are the secondary memory. Okay, that store the data permanently. So that is not the answer. So RAM is actually used to data which is currently executing. Okay, so question number 13. Which of the following are example of input device in a computer system architecture? Select all that apply. Input devices.
Uh, Keyboard, web camera,
Camera.
mouse,
Okay.
Mouse, mic.
Okay. Mouse is
and a
also
mic.
mic. Okay. Fine. So printer is a output device. Speaker is also a output device. Okay. Fine. Yeah, these last two questions are little bit about that you can just explore this. So what was the memory is used for these? So this is not a like a course related too much, but just to knowledge basis. Okay. So these processor, how much memory they had actually IBM mainframe systems that you how much memory actually they used Apollo 11 at that time, what main memory they used actually you can just search. Okay, and check what is the correct order. Identify the correct order. Oh, it is not mentioned that it is increasing or decreasing. The following order is how much main memory
Sir,
they had.
actually, it is mentioned Arduino Uno in fourth step.
No, I'm asking in this question. It is not mentioned that identify the correct order in increasing or decreasing memory size. This is
Yes, sir.
not
It's not
mentioned.
mentioned.
Okay, but you can explore this. How much memory actually they used? Arduino Uno is the I think very small RAM memory. So Apple iPhone, how much memory they used actually. So then you can just identify that what memory size they used in the as a RAM memory. Okay. So these last two questions are not much content related, but just you can explore search in the Google. Okay. So last, which of the following are computationally equivalent in theory? So the two processes are considered computationally equivalent if anything that can be performed using one can also be done by the other or vice versa. So computationally equivalent means if like are they capable to perform this ALU operations? So every processor are capable to perform this arithmetic or logical or these type of operations internally. So actually all processor basically are capable to perform this type of operations. Here we are talking about the that computationally equivalent definition is also mentioned. So here the answer is all of the above because all are capable to perform the basic computational operations, which is the required by the processor. Okay. So more detail you can explore a little bit about these last two questions. This is just added like as for some exploration. Okay, so now these are the PA questions. You can solve the graded assignment now. Now comes to the next step for the little bit to discuss about the programming. What is the required things? So, okay. So basic thing regarding the programming program. So what is the step program is a set of instructions you everyone know. Okay. So every program So we have some input. So every program you will, if you have any problem, okay, if you have any problem, you will always get a input. Okay, and input data you will process, and finally you will return some output. Okay, so this is the process to solve any problem. Input, you will receive some, you will process that input. Process means, what is the meaning of this process? So some logic, actually. This is the logic part. Or how you will build a logic, so that is actually set of steps, or we also call this as a algorithm. Okay, so processing means we are just processing on some input data and we are getting final output. For process, we required some logic according to the problem statements, how we can solve the problem. Some logic should be there. That logic should be written into some set of steps. Okay, set of steps, that is called as a algorithm. So algorithm can be written in any ways. You can simply write the algorithms steps in your language, okay, English or any language which you know. You can write just steps how you will solve the problem, okay, on the copy pen. After that, then after you find out the set of steps which you are performing to solve any problem, you can write a pseudocode. Okay, or algorithms we also represented sometime using with the help of flowchart. So flow algorithm is just like a simple statements you can write in any language, but flow chart is just like a visual representation of your steps. So how your flow is actually going on in the steps. Okay, so according to this name flow, we are just representing the flow of execution with the help of some graphical representation. Okay, so that is called as a flow chart. So what steps you are performing in the logic, that you will represent into the graphical representation. Okay, so that become a flow chart. So this comes under the same category. Either if you are comfortable with the algorithm, that is fine. If you want to just represent a completely flow chart, that is also fine. Okay, both represent the same steps, sequence of steps or logic. And next step is, you can convert this algorithm into a pseudocode. Pseudocode is nothing. This is closure program. Actually, this is not the, or we can say that this is a rough program. Rough program. Okay, this is not the exact correct program which is written in any language like C or Python or any language. We can write just like a, we are just converting this set of steps into a rough program. So here you are, suppose if you are running a loop, okay, so you can simply like write like as a for I in for I, or like this, for I equal to 0 to 10. You can write like this, okay, but this syntax will not work in editor of any C compiler or anything, but you can understand that you are just running a loop for from 1 to 10. Okay, so code is just like a rough program, and after writing the pseudocode, that convert into a main program. Any C program, Python program, anything. Okay, so logic is always remains same. So this final program may be different if you are using different programming language. If you are solving any problems, so this algorithm or logic will always remain same, but you can convert that logic into any programming language. Okay, so C, Python, or anything, you with the help of that language syntax or rules. Okay, so this is the sequence of steps. You should understand that how we will solve the problem. So any problem, first read the problem statement carefully, what problem is actually asking, and after that what input you are getting, and how you can process that input to get the output. Just define the logic for that, and then after getting the logic, just set your logic into a set of steps, and that convert that steps into a program. So this is the overall idea of the programming. So now let's discuss some uh, basic problems. I hope, let me share with you. This is some, okay, some sequence is disturbed. Okay, now you can see this is the first problem. Checking if a number is positive, negative, or zero. Okay, now you can understand that how, what is this problem. So we are getting a number. We are getting a number as an input. So number we are giving, and after that we will identify that this number is a positive, negative, or zero. So what should be the step for this? Okay, so this steps I am talking about, you can just take how you will solve this problem. Just think about that. Just take paper and pen. If this if problem is big, here you can think very easily for this is the basic problem. Any number is given, suppose this number is n. Okay, how we will identify that this number is a positive number or negative number or zero. So some condition you have to apply in your mind, correct?
Yes, sir.
Okay, you have to compare this number with some value. Okay, then you can identify that this number is a positive or negative or zero. So some conditional operation required to perform this operation. Okay, so that is just like a logic. So to identify that this is a positive number, so if you have to check like this, if n is greater than like 0, so that means positive. If n is less than 0, then that this is negative. If n is equal to 0, then this is equal to 0. Okay, so these three conditions you have to check in your logic, then you can identify the result. So in this way you can just define your steps. So now you if you are looking any number 10, you can directly conclude that this is a positive number by just looking this number. But how computer will identify this? So you have to just instruct to the computer how this should how you are checking actually. You are checking with the help of some sign, or just visibility, but computer
Some
will
logics.
computer will read this as a data, but you have to just instruct to the computer how it should check. So you have to define some set sequence of steps uh, which computer can actually perform. Okay, so in this way these steps, now if this is very clear, and this steps should be valid for any input. Okay, so after writing the steps, second step is actually just validate your algorithm or logic, validate your logic. So just check n is equal to suppose minus 20. How your steps are working? Take the input and minus 20. Okay, so minus 20. If n is greater than 0, no, minus 20 is not greater than 0, so this condition is false. If n is less than 0, yes, so this condition is become true. This is false. So you can see your logic is working fine for this input. Just check, pass another input like 0. So then how your steps will work? Okay, so your steps should be written in this way, so that should work for the every case, not only for the single digit. Do not write the steps for some specific input. Okay, and problem is given like to identify this number is a positive, negative, or 0, and suppose you are just considering that n equal to 15, and you are writing the your logic just looking this number only. Okay, so your logic should be valid for the every type of input. So here example is given, you can validate this, and you can if your logic if you feel that your set of steps are working fine for the every type of input, then convert this into a program. So this is the first step to solve any problem. Okay, so let's move to the another problem. So this is the same. Okay, next is finding the factorial of a number. Compute the factorial of a number. So suppose if you have n equal to any number like 5, so how you will calculate the factorial for this? Oh,
5 multiplied by 4, 3, and 2
hmm,
and 1.
okay, so that means factorial
We
means
can multiply with
so factorial means Like if we have n, so 1 into 2 into 3 into 4 into 5. This should be the calculation. Okay. So now you know that this is the calculation. We should multiply from 1 to 5 every number. Now write these into the steps. How you will do this? Okay. So you can take like some result value and you can assign to 1. Now after that, because this is a iteration, you are multiplying some value with the another value. Suppose this is 5 steps, but suppose if you have n equal to 100, okay, if you have n equal to 100, so you have to multiply from 1 to 100, correct? So you cannot write like this, if like r equal to r into 1, then r equal to r into 2, like this type of steps is not
I will use for loop.
uh So if you're writing this here n equal to 5, you are writing 5 steps, so that will only perform 5 multiplication, but n may be anything. So here you have to use a loop actually. Okay, so to perform this, you have to use a loop, and using the loop you have to decide your iteration, number of iteration, how many times you want to multiply this. So you can start with one, your loop with 1, and run till n, and every time just add, suppose I, you are taking I equal to 1 to n, every time you can write like this, r equal to r into I.
I is equals to less than 100.
And condition you have to mention in your loop condition. Okay, so how we can just write like a steps for this. So you can see, initialize factorial equal to 1, multiply factorial by each number from 1 to n, and the result is factorial. This is the output. Okay, so here the second step, how you can perform in the programming, so that you can perform with the help of loop or iteration. Okay, so you can see factorial equal to 1 into 1. So in this calculation, in the example, what we are doing, we are multiplying 1 into 1, 1 into 2, and the final resulted value, this value is now coming at this place, and this sequence you can see, this is incrementing one by one every time, 1 2 3 4, and every time we are multiplying into the previous result. So you can manage this sequence 1 2 3, this is incrementing by 1 by some variable I. Okay, you can set like for I equal to 1 to n, and inside this is this loop, you can just perform r equal to r into I, and initially r you can set start with 1. So now your task will be done. If your value n value is 5, so that loop will run I equal to 1 to 5. So I value will be change in every iteration. Okay, so I first value will be I equal to 1. Okay, second iteration I will become 2. Then third iteration I, so loop is automatically incremented the value of I. Okay,
It's a
for loop.
pre-increment, sir.
Sorry.
Pre-increment.
How you can do pre-increment, you can do post-increment, any way you can do. So any problem can be solved. You can write a different implementation, different syntax for to solve any problem. There is not a fixed actually. Any problem can be solved in different way also. So what way you are writing the implementation? If your implementation is providing always correct output, your implementation is correct. Okay, either you are using while loop or
Okay,
using
sir.
for loop, or any type of loop you are using, any how you are doing the increment. If you are writing like this, r equal to r plus 1, if you are only writing this like r plus plus in the C language, so there are multiple way to perform a, a specific task. You can use any type. Okay, your task should be done. Okay, so this is the one example. You can see how we can just find out a logic, and after that we can convert that into a program. So that is the next step we will discuss from the week third. But first you should identify your logic actually, how you are solving the problem. So next is checking if the number is a perfect square. Okay, how you will do this? Suppose any number is given, n equal to like uh, this 35.
4.
So how you will check this? This is a perfect square or not? Perfect square means any number like 36. So this is the perfect square of 6 into 6. Correct? So we can see that this is a perfect square of any integer number. So how you will solve this problem step by step? How you will check? For programming, you have to think like as a computer. Okay, don't directly conclude. Uh, do not directly conclude based on your pre knowledge. Okay. Now you are a programmer. You have to tell to the computer how this problem should be solved step by step. Okay. So how you can check this? Any idea? Anyone? Step by step, how you will check this? Yeah, Arvind, go ahead.
So I was thinking, like, if we are taking the number 36,
Huh.
we will take first we'll divide the number by 2. Like, uh, if we divide the number by 2, we will get 18.
Hmm.
Then up to 18, we will be multiplying the numbers by itself, like 1 into 1, 2 into 2.
Okay, you are saying 1 to 18.
Yeah.
You are checking 1 into 1 and
Yeah,
then
then
2
2
into
into
2,
yeah.
3 into 3. Yeah, okay. So you have just reduced some operations, so that is nice. Otherwise, the same things we can do with 36 also. That is not incorrect actually, but that is just an unwanted operation.
Yes.
Huh. So yeah, that is correct approach. Okay, so what we can do to identify that number is a perfect square or not. So till 36, we have this number n equal to 36. Okay, so what we can do, we can just run a loop. Okay, so I equal to 1 to 36 I am running. Okay, I am not talking about the efficiency or that in this first level course. Okay, anyway, you should solve the problem only. So I equal to 1 to 6 and check for each number if 1 into 1. Okay, so if 1 into 1 equal to 36 or not. Okay, not. Just check the second value. 2 into 2 equal to 36. No. 3 into 3 36. No. Okay, so in that way check for each number, and in some place this loop will run for the every value from 1 to 36. At any point, if you are getting this equality true, okay, so 6 into 6 at the sixth iteration, you will get this condition true, 36. Okay, both side value are equal. So at that time you can identify that this number is a perfect square. If your loop is completely finished without finding any number like 7, if you're running a 7 to check, okay, so 7. So for 7, 1 into 1 is not correct, 2 into 2 is also not getting, 3 into 3 is not getting, like this. Any number you will not get. 5 into 5, 6 into 6, 7 into 7. Any condition will not be matched like this, okay? So in that case, if your all checking is completed, still you not get the equality true, then you can return this is not a perfect square. Okay, so in this way you can check this number is perfect square or not. That is the different thing. Square root, that I am not talking about any specific function because I am not using currently any programming language. So yeah, that is also one efficient logic for that. Why we are checking for all like 36? Why we are checking 1 to 36? Okay, so because this question itself also asking this is a perfect square or not. So if you have directly square root function, so you can directly check by just looking the integer. You can find out the square root of this, and if convert that into a integer value and that check the square if it is equal to or not. So that is the different things, but we are just looking on the step by step task. Okay.
Sir,
Huh. Okay, so you can see this is the steps we can write like this. Start with a variable x equal to 1 while we are running a loop x into x is less than or equal to the number. Okay, check if x into x equal to the number. If yes, the number is a perfect square. If no, increment x and iterate this loop because this is running inside the while loop. Okay, if no such x is found, it is not a perfect square. So same steps we have written what we are trying to use to solve that this. Okay, next is sum of number from 1 to n. This is simple straightforward. We have already seen this into the factorial when we multiply from 1 to n. This time we are just performing sum of number from 1 to n. Okay, so you have to iterate the loop here also. Okay, so your task is 1 to n addition. Any formula, any, if you can remember, we can directly apply for this.
N of n plus 1 by 2.
Okay. Yeah, s equal to n into
n plus 1 by 2.
So some this type of logic. So this problem we can solve like this. So we can take I equal to 1 to n and we can set s equal to initially 0. And inside this loop, we can just always add s equal to s plus I. Okay.
Plus.
This is the one way to solve using the iteration. Okay. So every time we are reading I equal to 1, we will add into s. Then I equal to 2, we will add into s. Okay, so in this way we will get list like this: 1 plus 2 plus 3 plus 4 dot 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 n. So you will get a answer. But another formula you can directly use this for this calculation. Okay, n into n plus 1 by 2. If suppose n equal to 5, so 5 into 6 by 2, this is 15. Okay, so sometimes, so as I mentioned that any problem can be solved with the different logic also, different way also. So what logics comes in your mind first, you can apply. Okay, you can think, suppose if you're thinking the logic, what logic comes in your mind, but that logic should solve the problem correctly. Okay, so don't just look the another solution, so how the another person is solving the problem. So that is just not only the way of the solution. Okay, there is a multiple possible way to solve any problem. So this is the answer, and if we move to the next, so this is the process we have mentioned. Okay, now this is very popular, this checking if a number is prime or not. You know what is the prime number? Anyone?
Yeah, the number which is divisible by itself and 1.
Okay, correct. Yeah, any number which is divisible by itself or 1, that is called as a prime number. But that 1 is not considered. So any number is less than 2 is not a prime number actually. Okay, so that is also a one condition. So we cannot take like as a 1 is a prime number. Okay, 1 0 minus any negative value, all these are not prime number. We check this prime number for any value from 2. All this side, all are not prime.
Sir, any number which has only 2 factors is called a prime number, right?
Yes. 2 factor means one factor and number itself.
Yeah.
Okay, but from this range 2 to positive side, this range, this side range, we all consider all the number as a not prime. Okay, so now this is the this is the definition of prime number. Now how you will check this by step by step? How you will identify? Suppose n equal to like 11. How you will identify that this number is a prime or not? How you will write a steps or how you will define a logics?
Number less than 2 is not prime, sir.
So all these negative number, all these considered as a not prime. We check this prime number after this one. Otherwise, according to the definition, if number is divisible by 1 or itself, so this is also satisfied that 1. Okay.
And the number modulo is equal to 0 is also a not prime number.
If the number is divisible by any of these, it
Huh.
is not prime, like 1, 2, 3, 4.
Not one. Do not include one.
Sorry, sir, 2, 4.
Hmm. Okay. Any value. So this 11 is can be divisible by 1 or 11 only. Okay. So this is the factor. It cannot be divisible by any number from in between this 2, 3, 4, 5, 6, 7, 8, 9, 10 till 10. So this number is a prime number. So now how you will check, not you, how the computer will check this.
So first step, like take a number 29, and first step 29 is greater than 1. Second test divisors 29 divided by 2 is not
29,
integer.
why you are taking 29 directly?
29, sir, it's a prime number.
No, no. Why only taking? Suppose I am checking 47 is a prime number or not. So how you are deciding this 29 for
Okay,
checking?
sir, 47. 47 is divided by 2 is not
Sir,
integer. 47
sir,
is
we'll run
divided
a
by
loop.
5.
Ha, ha, ha. I think he's also saying the same thing. So you are
Sir,
saying
we'll
that.
run a loop from the number 2 to the number itself. And if any number, sir, will take the flow division which gives on, so which leaves the remainder. Or sir, we will take the remainder value. If the remainder is 0, then it will be prime number.
Yes, correct. So yeah, for to solve this, what we can do, we can check if this 47 n, we are just considering this as a n may be anything. Okay. So n may be anything. So we will run a loop from 2 to n minus 1. Okay. And suppose this is I. And for every time we will check if our n is divisible by this I value, means remainder is 0, this condition. Okay. If any number, any I completely divided this n, then this number is not a prime. If our loop is completely finished, still we not find any condition when our number is divided completely, then we can consider that this number is a prime. Okay. But before 2, if suppose if our n equal to like 1, then we can directly return as a false. So what we can mention like some condition, if our n is less than 2, then we will directly return answer not prime. Okay. But if our value is greater than or equal to 2, so then we will check by this loop condition. So we will divide our number by every number within this range. If our we at any time we found this condition true, we will just return back our number is not prime, otherwise prime. So this is the step. So that means you have to iterate one loop, you have to check the division by every number. So n by 1, n by 2, sorry, n by 2, n by 3, n by 4, like this. For every condition you have to check. At any point, if we this condition become true, so output will be a not prime. Yeah, so this is the logic, or this is the set sequence of steps we can consider to solve this. So that is written here. uh, so if n is less than 2, we can directly return not prime. Okay. Check divisor of n from 2 to square root of n. Yeah, this is just write a efficient approach. Okay. We are just no need to check from 2 to n minus 1. If you just complete this range to further checking 2 to square root of n, still you will get a correct answer. Because any number, why we are taking square root, suppose we are checking for like 18. Okay. So what should be the checking, like 1 into 18 you are getting. Okay, you are checking for 1 divided by 80, but we are starting from 2. So you can see you are getting this factor 2 into 9. Okay. Then for 3, 3 into 6 you are getting. Okay. 4, you are not getting any integer value for this to get this. Okay. 5 into but if you are getting this like 4. Okay. So 4 into some value, so 4 4 is 16, and for 5 it become a 20 greater than this. So let's 5 it is increasing, but the next step you can see after this step this 5 is coming here, so this side value should will be decreased actually. Okay, so now 5 into 4 become more than this. Now 6 into 3, so you can see after this process this is just like a reverse of the previous process. So you can see 3 and 6, 6 and 3. So same things we are checking. So like 7 into, we are not getting correct, but 8 then 9 into 2, so that is just a reverse of this step. So we can only check till square root of value. So that means what is the square root integer value for this 18? So that is integer value we can consider as a 4, and we can check till one more than this. Okay, so 5. So 2 to 5 we need to only check if we are getting our output correctly or not. So after that it cannot be divided. Okay, so 18, so 18 is completely divisible by 2. Yes. So like suppose if we are checking 49, so no need to check the divisor value till 1 to 49. You can only check 1 to 7. Okay, so this is not, sorry, 2 to 7. This is not divisible by 2, this is not divisible by 3, not 4, not 5, not 6, not 7. Yes, 7 it will be divided. Okay, so your loop range may be from 2 to square root of n. That will also work for this. So this is just a efficient. We are not just thinking like this in the C level course, foundation course. That is the next level course when we just learn the efficiency, that is called as a data structure and algorithm. Okay, so this course just only focus to solve the problem. Doesn't matter what is the efficiency of your code. Okay, so how you are solving this. So now these are the way to identify the logic and how you can write that logic into the steps. And after, once you will get a set of steps, then that steps will be converted into your program. So that is the main task we will learn into our course. Okay, so now one more thing for the basic structure. Okay, so that is I am sending this link into your chat. You can just join this. I'll discuss about the basic structure. I've sent in the chat. So this is an invite link for the online GDB portal. So you know about the online GDB portal. This is a compiler, online compiler, and you can write a program into any language in this. Maybe it will take some time at the first time if you are opening. So you can see you can use this compiler for practice, C program practice. Here on the top there is a language you can select, like C. We are learning C. Other languages are also available, but select C here, and then you can write a C program and run. Okay, I have sent one link. Anyone are able to open the link?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
you will get after just clicking on that link, just join through your any that student email ID, and you will get a, so I think it will ask some registration process, like you can just join as a student. Okay, so after joining as a student, just fill the entry. I think some entry will, it will ask, but after getting, you will see this type of one classroom C programming, that January 2021 live coding. Okay, week 3 onwards we will practice on this platform in the live session, but I have just released 3 basic problems for this. You can start with, we will discuss. So anyone are able to see these problem 1, problem 2, problem 3?
Yes, sir.
Okay, fine. Okay. So let's open the first problem. So I have configured three problem. So that are very basic problem, and we will discuss how to write the code and how we will use this. Okay. So this is the problem statement you can see. Huh. So right left side you can see the problem statement. Right side is a editor. Okay. So this is the area where we will write our code. This black area. Okay. So this black is just called as a editor where we are writing our C program, and we will run that our code by using this run button. Okay, because these problems are configured as a test problem, so we can also we have also configured some input and output. Okay, so that input and output should be matched according to the problem statement. First thing, this type of interface you will also see from week 3 in our portal also. Okay, so this is the another portal, online GDB, we will only use for the live coding session. But for the programming assignment on the portal, you will get a another portal. Let me show you in the previous term. Okay, so one example. One second. Okay, so all actually you can see this is our course portal assignment interface. Okay, programming assignment interface. So here you can see, you can read the problem statement on this side, left side. Right side, this is the area where you will write the program. Okay, and language is already by default selected. And test case, you can also see what is the input given to the program, what should be the output. Okay, so this is also given. When you will run your program, your output will also be visible. For this type of platform where all information are already pre-configured. Okay, so problem statement configured, input output is also configured, so that is actually called as a online judge. Okay, online judge, that actually online validate your solution. Here there is no manual requirement for the your solution code validation. By default, this automatically validate your solution with the expected output or your code output. So in this type of scenario, your output format should be exact similar to the expected output format. This is the very important things regarding this programming assignment. Okay, what type of output we are printing, for this, let me take simpler one. So suppose this PPA. Huh. So complete the program. So you can see, complete the program to calculate the sum of first and natural number. You are given an integer, calculate the sum of first and natural number and store the result into a variable sum. So this is the problem statement. Here right side you can see this dark area, actually this is the fixed area, fixed code which is already written, you cannot update this. There is white area in between where you can type your code. Okay, because the deadline is already passed, this is the last term assignment, so I cannot update right now. So here this is the area where you have to write your code. Okay, when you will write your code, you will run this. So there is a run and test run and submit button will be visible when this assignment will live. So you can click on the test run button, and then test case will actually execute. So in this input will be passed to your code, this should be the output, and your code output is what code your output is returning. Okay, so if anything is different, suppose if you are printing the output like the sum is 15, okay, but expected output is only 15 numerical this part. Okay, but you are printing something like the sum is 15. So in that way your output will not be matched, or your test case will be failed, you will get a 0 marks. So in this type of assignment, your output format should be exact similar to the expected output format. Okay, only then you will get a marks, or then only your test case will be passed. So this is the prerequisite to understanding regarding the programming assignment. So same things I am writing here. So this online GDB portal. So here the first question is, write a C program to print the message hello world. So you can see what is the message actually here. Yes, Anti?
Hello, sir.
Yes.
Sir, when I'm logging, I don't find the questions.
Okay.
After login,
Mhm.
re-click the link given by the sir.
If you can directly click on this link, that will directly open the online GD portal, but you have to register yourself first as a student.
Okay, sir. ठीक है.
Okay. So this online GDB is similar to the Rapid. Yeah, most of the online editor are very similar. So that is also, so this classroom, actually I'm using this feature of classroom, but you can directly use for the practice online GDB. Okay. So just write a program and just check the output. So I'm just writing a very first program here. Okay. So I'll just discuss the every part here. So has include. Okay. Okay, let's run this. So see what output we are getting. So the this ever part, basically this ever part. One second. Okay, so this part is actually a editor part where we will write our C code. Okay, and this lower part is called as a console. So this is the interface where we will get our output. This is generally called as a standard output or standard input interface. Okay, so this is called as a console. From console we can interact with our program. Okay, we can pass at the runtime. So this when we are typing the code, that is just like a file. Okay, while we are just creating a file, text file, like a as a text file, we are just writing a set of syntax or set of instructions in the C language. But when we will run this code, so that code will be converted, this file will be converted into a different machine code files, and that file will be executed by the processor. So that is called as a compilation process. So, and after that our program will run. Okay, when our program will run, at that time we can also interact with our program. So either our program will after running our program, that will return some output, and that output we can display on our console. So here in this code you can see when we run this code, so output is displayed in this black screen or this part. So that is called as a console standard output. So our code is executing by the processor, and this print statement is actually printing something into our console output. So that is display here. So that is the one thing how we can display our output into the console by the our program. Same things we can also read the input into our program. So that I'll also explain here. But first thing, what we are doing in this program, step by step. So has include, just you can remember this structure. This is the basic structure you will use in every code. Okay, and what is the purpose of this? So first thing is has include stdio.h. So this is called as a preprocessor directive, and before executing the your code, this actually in some preprocess happens in your code. And what is this preprocessing means? We are including some predefined library means where the some code is already written predefined. Okay, and that code we are directly using in our code. So suppose here we are writing this printf. Okay, so this is a function is we can consider as a block of code. Okay, function is predefined, or function is just a block of code, and we are calling that function. Okay, so printf and square open bracket and close bracket, same type of structure you can see here, main open bracket and close bracket. So this is also a one function. Okay, so this name of this function is main, and function always contains some body means some block, set of instruction we can put inside that block. So similarly, printf is also a function that is already defined inside some library of the C library, that is called as a stdio.h, standard input output.h. So definition, what we are doing inside this printf function, that is defined inside this library. So we no need to write every details of this, how our output will be displayed into the console, how this operation is performing. So some predefined operation is already given by the programming language, so you can directly call that function and you can perform your task. So if we want to use this printf function, we have to include this library in our code, standard input output library. Same things, if you want to read some input from the console, we have to include this library in our code. So this is very basic library, we will always include in our code, because every program will read some input and will display some output. Okay, so this printf, and there is one another operation, scanf, that is used for the reading the input. Okay, so with that we will always use in our code. So this library, you can just right now you can consider it, just you will always write this before the program. Okay, has include stdio.h, because we will always use our print statement and or sometime input statement also. So this is the prerequisite, and we are including this in our code, stdio.h. After that, this is the main function actually. This is the main function, and this is the identification that to the compiler, this block actually will execute first. Okay, this function will execute first. You can write multiple function similar to this main function in your code. So this is a int main, like this is the open bracket, so this is the identification of function. We will discuss in much detail in later week also, but right now this one required function is main in your code, that is always execute first. Okay, suppose if you are also writing another function like add or some multiple or some print, any other functions also, but always the main part code actually will execute first by the compiler. So this is the prerequisite of this uh, any C code. So this is the main structure you can remember right now. Later we will discuss in detail. So the main body, inside this body, what is the first instruction we have written? Print f hello world. Okay, this is the first instruction, and this is the second instruction. But the second instruction is used by the operating system, not in our code. So let's just discuss. So what I'm writing here, printf hello world. So this hello world is a string, and this string we always write a string inside this double quote. Okay, so this string we are giving to this function, printf function, and this function already defined inside this library, and the purpose of this function is just to pass this string which we are passing inside this print function to the console. Okay, as a output here. So suppose if you have multiple line, so let's when I'm running this, 1 second, when I'm running this, you are getting hello world one time. So now you can see if we write this multiple time. Okay, so you can see how the execution is happening. Like I'm just defining differentiation in this all is print statement, and to make this in the new line every time, you have to use /n after every, like, okay, so this /n is actually point, just change the pointer location to the new line. uh and Okay, let's run this code and you see what we are getting. So what sequence output we are getting. So this is the first instruction to the computer that is displaying the output into out to the console what we have written inside this. Okay, hello world. but but this slash n is actually pointing to the next line, to printing the next statement. Okay, so this is just a identification to the compiler that move to the next line before printing the next statement. Okay, so next line will be print. If you not add this, so what will happen actually? So you can see the first line and second line is coming into the one line. Okay, but if we will add this, so now this second line will also come into the second output. So the instruction sequence is from first line to last line, top to down manner. Okay, so in this way you can print, you can display anything into your output console. So this is the, and written, this thing is actually okay, we have not covered too much right now. So we have writing this main function, and the return type of this main function is integer. So this is the first part of this function is called as a return type. If we have defined this as a integer, so that means this function should return some integer value to our operating system. Okay, for main actually we will consider this as a operating system information. So 0 is considered as a successfully execution. Okay, if our main function is returning 0, that means our program is successfully executed without any error or any like a machine error or something. Yeah, yeah, Ravikant.
Hello, sir. Actually, I want to print same lines for multiple times.
Huh.
Can I do loop
You
for
can
it?
use loop. Definitely, we will use the all information later. Okay, so right now I am not discussing that much detail. That is the B4 content actually, conditional statement and loop. So I am just discussing only about the how we can print the output and how we can read the input like this information. Okay, so that is the
Actually,
first,
loop.
that is the first part actually of the
ac-
program. Hmm.
Sir, actually, loop handle the numericals part, that is 1, 2, and so on.
I know that.
But
I know
how
that.
can I? But how can I print a multiples line by a same command, by only one command?
So that we can do with the help of loop. You can see this time I have written this 5 times, so this is printing 5 times. Okay, but using the loop, then you have to write this statement inside for loop. So like for, I'm writing here, but don't think much about this syntax. Okay, because this is not discussed yet. I equal to 0, same things we are using one loop here. Okay, I equal to 0, and now we will set like I is less than equal to 10. Okay, and this is the I plus plus. Okay, and inside this body we are writing this print statement. Okay, so now this become a loop, and what statement is written inside this loop will perform 10 times. Okay, we are just running 0 to less than 9. Every time this will incremented by 1, I 1 2 3. So if we run this, you will get 10 times hello world. Okay.
Okay, I got it. Thanks.
But I am not discussing that here right now, because I am just focusing on the input and output process. So if you want to print anything into your output console, so you will use this printf statement. Okay, this is used for the display something to the output console. Yeah, someone raised the hand in between. Any query? Oh, Linux is class is there, but C is a prerequisite for the Linux, I think. So okay, so let's quickly discuss this question. So how we can print something. So the first assignment question is given like this. So just print this statement. So you can write the code for this. Okay, so just do the practice. If you want to learn programming, definitely write many of the codes in your editor and execute. Okay, then you can understand everything well in the C code. So just write the same type of structure here. So has include stdio.h Okay, this is the standard library we have added, like that int and main function. So inside this, just mention this return 0 for the operating system, and before this mention the print f. Now you can you see, if I'm writing hello world, okay, and test your code, your code is returning a correct output or not. Okay, so how we can validate this? So here there is one button, test button. Suppose if you run this code, you will get a hello world, but according to the question this is correct or not, then we will validate from test button. Okay, test, there is right button, test. When you will click on this test button, you can see hello world. Okay, so pass. Yeah, this is passed. I think this is this exclamation marks is not written configured. Okay. So your output is matched. Suppose if you are writing like this hello only, okay, hello, then it will pass or not. Let's see. Now you can see fail. Here input is, there is no input for this problem, okay, and your output is hello. Expected output is hello world. Okay, so this is missed actually. This should be hello comma world exclamation mark, but we have configured mistakenly this. Okay, so you can see your hello is not matched with the expected output. Because of that, this is failed. Okay, status you can check. This is not matched exactly. So your output test case is failed. So once you feel that your output is correct, so in that case, you can submit your code. So now if you run this, now status of this code is pass. Okay, so pass. Now if you feel this correct, you can submit this. Okay, so now we will get your response. Okay, you have submitted this code correctly or not. Okay, now submit. If you want to resubmit again, just you have to click on this resubmit button, and then you, this will be enabled to again to resubmit. Okay, so this is the output process. Let's move to the second problem, how we can read the input. I'm quickly giving some demo for the code, and do not worry much about this syntax right now. Okay, we will use this multiple time later also. Huh. So how we can read the input from the console? Okay, so how we can read the input, any integer from the console, and how we can print that. So let's discuss here. Okay, suppose this is the predefined, we have mentioned that this should be printed, but now this time we will read some integer value from the input and will print that integer value to the output screen. Okay, so how we can do this? Because most of the problem you will always read some input and then process that input and then will print the output. So how we can read the input? So what type of value we want to read? First thing, this should be very clear. Okay, so suppose we are want to read a integer value, so you to store that, so you will read a integer value, but you have to store that value in some place in your code memory. So that we generally we define some variable first. Okay, let int a. Okay, so this a is now a variable that point to some memory location. At that memory location we will store our data. So to reading the data from console, we use this scanf, and inside this percentile, what type of data we are reading and where we will store this. And so this is a little bit syntax, maybe you will confuse with this. So what we are doing, scanf means we are reading some input from the standard input. Okay, from the console. So this first part is indicating that we are just telling to the compiler what type of value we are reading. Okay, so for integer we use this specified d, percentile d. Okay, for character we use percentile c, for float we use percentile f. Okay, so this we will learn later also, but right now you can just remember for integer we use this percentile d. So this is just a identification that what type of value we are going to read. Okay, and where this value will be stored. Okay, so we have written this and symbol a. Okay, so we want to store that value into a variable, but a is just like a label of the memory location. Okay, so we are just finding, we are just telling to the compiler at this memory location. So what is the location? Memory location of a. So this is the just a operator which actually return the memory location, memory address of the variable a. Okay, and symbol. This and symbol is just returning a memory address of a, and that memory location our data will store. Okay, and same data we want to print. Okay, so how we will print? So like the output output is okay, and we have to pass this variable like this a here, comma a, but we have to mention the location. So this is called as a string of format, formatted string. So where we are passing some variable value into our string. So this is the string area. If we want to pass some value inside the string, so we use this specifier again, so percentile d. Okay, so what is the meaning of this? This is complete string inside the double quote. This is the complete string, but this percentile d, this will be replaced by the value of a. Okay, so what is the value of a? That will be located here. Okay, so what data we will read? So that will be replaced this percentile d. Suppose we are reading a equal to 10. So the output will be, the output is this percentile d will be replaced by this value of a, 10. Okay, so this will become the output is 10. So let's run this, how it will actually interface. So you can see when this code is running, so this line is executed, at this line our code is actually stopped, and it is waiting for our input from the console. You can see console, when I run this code, this is blinking in the console, and it is waiting. This code is not executed completely right now, it is stopped at this line. Now we will pass some input like 15. Okay, and enter. Once we will press enter, execution will start to the next instruction. Okay, so this print line will execute. So at the time this value of a will be passed to this statement, and you can see what output we will get. You can see the output is 15. Okay, so input we are reading like this, and the a value we are printing in the print statements. Okay, so this is the way of output. So this way we can read the input and store that input, because if you are reading anything, we have to store in some place in our code. Okay, and then we will use that into our logic or something, and then finally we will print some output. So here this is the input part, and this is the output part, how we can print the value. So the second assignment in your online GDB classroom is this one. Just read some integer input, so you can see 42, and print this output. You entered colon 42. So let's yeah, one thing, you cannot use copy paste in this portal. Okay, so you have to type, because typing practice is must required for this. Okay, do not use copy paste. So has include stdio.h. Okay, so int main, this one, this is the same thing, return and 0, and before that just take some variable int, and you can give any name. Okay, to the variable, and then scanf percentile d. So we are going to read integer value, and we will store this at the end location. Okay, and we will print this. So printf. Now string format is, you can see in the problem statement, you entered. Okay, so this should be written as it is. Okay, you entered, and then colon, then space, and then write percentile d. Okay, and just pass the value for percentile d as a n. Okay, so now this is the code for this. We are reading the input. Yeah, Ravikant.
Hello, sir. Actually, I have another live session also from
Haha.
2 p.m. to 4 p.m.
Okay,
So I
fine. So
can handle two live
you
sessions.
can leave. I am also closing in only 5 minutes. Okay.
Okay, sir.
Okay, so yeah, you can see now we will test this. So we can first run and we can test our output. So if you are pressing 10, you enter 10. Okay. Now test this program to the pre-configured input. Okay. So first test case is passed, second test case is passed, third test case is hidden actually. Okay. So this type of behavior you will see in our regular programming assignment. Some test case will be hidden. You cannot see the input. Okay, but if your logic is correct, your test case will pass, otherwise fail. So public test case means you can see the input and expected output, but private or hidden test case means you cannot see the output. But here status is 3 test case passed out of 3, so that means your private test case is also passed. Yeah, someone raised the hand. Okay, so your code is fine, correctly printing. Suppose if you change some format, like you enter number, okay, same things, so this will not pass the test case. You can see fail. Okay, so format is very important in this type of assignment. So just always follow the questions statement correctly. So this is correct, and now you can submit the code. Okay, if you feel that your all test case pass, submit the code. Okay, so now third question you can try. Now input reading and output I have mentioned. Third question just like is addition of two integer input number. Okay, so that you can try. So third question we are reading. So is 20. Oh, okay. We are reading two input 12 and 8. Okay, and our output should be the sum of these two input. So use the both information, how we are reading the input, how and we are storing into the variable. So you can use the same information and try by your own. Okay, next week we will discuss more example. Okay, just try to. So deadline I have set tomorrow for this these three questions. So just complete before that. Okay, so I hope any if you have any query you can ask. Otherwise we can close already. Sir, where I get this link? Okay, I have sent in the chat. I am again sending in the chat. 1 second. Okay, just click on this link and join this. Okay, so in this Saturday live coding session, we will practice on this platform for the programming questions, mainly from Week 3. Okay, then bye everyone. Thanks. Sir, give some tips regarding learning C. Yeah, practice, 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 and professor have also mentioned this word in their session. Okay, just writing practice, code practice. 1 second, I am closing the streaming. Yeah, yeah. Please ask.
Sir, is if we